All right, it says we are live. Hello, everybody, and welcome to our very first Footsteps to Mars Hangout here on Deep Astronomy. My name is Tony Darnell, and I am so excited about tonight's hangout because we're going to be talking about all kinds of cool things related to exploration to Mars, putting human presence on Mars, and this will be our first one. Before we get started on the hangout, let me give you a little bit of background on what we're going to be doing with this. This hangout will be scheduled on the first Friday of each month, of which this is today, and we're going to try both Harley. Alberto and I are going to try and bring you the latest news, information, and science related to our efforts to bring a human presence to Mars. So each month, hopefully, we'll be talking to astronomers, scientists, engineers, and hopefully maybe even administrators to discuss the bigger picture as well as the status of getting human beings on the surface of Mars. And we'll also have in-depth discussions along with to help understand some of the technical challenges facing us on such a big, ambitious endeavor. And so that's our goal with this hangout, and we will be holding it on the first Friday of each month at 3 p.m. Eastern Time. But if you need a reminder on how to find out about these things, what I would do is encourage you to go to the Deep Astronomy Facebook page. It's facebook.com/deepastronomy/events. And if you subscribe to that, you'll get notified of when the next event is going to be, and you'll be reminded. As well as follow me on Twitter at Deep Astronomy. You'll be able to learn more when the next one's going to happen. And today, what we're going to be talking about is we're going to be discussing the where are the landing sites of where we might put a human. Some of the first missions to Mars. Where are they going to land? And scientists and astronomers are already thinking about this, and they held a workshop back in October. In fact, I think they've held several, and they've been talking about this very problem with me. And our guests tonight are going to help us understand what the challenges are of the different kinds of landing environments, landing spots, and what they're converging on, if anything. But before I get started with that, let me introduce my co-hosts. Joining me, as he does every month, is Dr. Harley Thronson. He's astronomer at the NASA Goddard Space Flight Center. Hi, Harley. Welcome back.
Good afternoon. Looking forward to this first in a series of Footsteps to Mars Google Hangouts.
That's right. First in a series. And also joining me is my good friend, Dr. Alberto Conti, the innovation scientist and extraordinaire at Northrop Grumman, the main contractor building the James Webb Space Telescope. Hi, Alberto. It's good to see you again.
It's good to see you. I'm very excited about the Hangouts. It's outside my comfort zone, so I love it.
It's outside your comfort zone. Yes. You're not gonna let that stop you, right?
No, why should I?
That's right. And you're also in some exotic locale, as you always are.
No, just Los Angeles.
It's only Los Angeles. Oh.
Yeah, it's only Los Angeles.
All right. Well, let me tell you how you can interact with us. This is a hangout on air with the people here, but we also want you to give us questions and comments. So let me tell you how you can do it. First of all, you'll notice on my lower third it says Footsteps to Mars. That's a hashtag. If you use that on Twitter, I will go and look on Twitter for comments and questions that you might have for our guests, and I will read them out if they are nice and polite and worthy for and not too and safe for work, I guess I should say. Also, I have the live chat enabled for this hangout. So if you're on YouTube and you're watching this on the watch page, you can leave the live chat open. I have that as well, and I'm looking at it right now, and I see a lot of you already going crazy on it. So that's really great. Please understand that I am going to maybe have to scroll back on some of these, so you may have to type your question in 2 or 3 times because I'm also moderating as well as looking at this chat window. So those are the 2 main ways that you can interact with us today and leave questions for our guests as well as for Alberto and Harley as well. So today, as I mentioned at the top, we're going to be talking about where are we going to land on Mars when we do go there. And going to Mars, I don't have to tell you guys, it's a big deal. It's a very huge endeavor. But scientists have been already thinking about where we're going to start by landing. And joining me to discuss these things are people who think about these things all day long. Is Rick Davis. He's the Assistant Director for Science and Exploration in NASA's Science Mission Directorate. Hi, Rick, and welcome.
Thank you. It's great to be here.
Thank you. It's good to have you. Also with me is Dr. Steve Hoffman from the Exploration Missions and Project Office at Johnson Space Flight Center. Hi, Steve, and welcome back, and welcome to our Hangout.
Thanks, Tony. I'm happy to be here also.
All right. Well, we're looking forward to getting started here. Where to even begin? All right. So we're going to try and start with a certain. I want to look at the big picture of going to Mars first. And whenever we have these Hangouts, I want to always try and have, if there's some relevant news out there, to discuss it and talk about it. And just this week, there was some stuff that came out. There was some testimony given in Congress recently about to the House Science Committee, and there were some people who were talking about the fact that we're questioning the idea that maybe NASA isn't quite ready, or doesn't have a full plan, or isn't fully looking at the big picture for all of the things that it would take to go to Mars. And I just wanted to get you guys' comments. And Harley, let me start with you a little bit on this. Did you see what I was talking about with that testimony?
Sure. Yes, I watched indeed. Yeah, and folks who follow the sort of stuff, the House has archived that hearing on their website, so folks ought to take a look at it.
That's right. So, what did you? So, what? I guess the idea was that a lot of people are saying that. I guess some experts had come out and said, "Wait a minute, NASA's got a lot of big plans of going to Mars, but it's not quite ready for prime time yet." Is that sort of the gist of the whole thing?
Yeah. Well, NASA's human spaceflight policy is set by the White House with, of course, a lot of input from such organizations as the National Academy of Sciences and so on. And NASA has not settled on a scenario or an architecture for going to Mars. They're funding a large number of studies and key technology developments, including, for example, the space station, which is a key stepping stone going to Mars. It has identified a number of steps over the next 20 years or so. However, that is correct that the White House and NASA has not identified. Has not stated a highly specific architecture or scenario for humans to Mars. That's correct.
And so they were kind of, I guess it was, let me just clarify, it was the House Committee on Science, Space, and Technology. They were the ones that met this week and talked about a lot of this stuff. Now, Steve, you've got some experience with this, where you sort of helped draft some of NASA's. I don't know if it was their blueprint for this or what the right word might be, but you've got a little experience on this also, and you had some good insight. Now, Harley just said that it's really the White House that kind of drives a lot of what NASA is going to do and sets the mission. But you made a good point just before we went live about the fact that we're trying to plan something for 20, 30 years away, and yet the budgetary process is on order of a year-to-year kind of thing. So can you comment on that just a little bit, what you were saying?
Sure. The NASA, as part of the executive branch, responds to the White House, but it's also funded by the Congress. So the White House gets to tell us what to do, and the Congress gets to tell us what kind of money we can spend and how we can spend it. And that budget only goes for 1 year at a time, with some projections for 5 years out in the future. And the course that the White House has put us on says that NASA should have people at Mars or in the vicinity of Mars about 20 years from now, in the mid-2030s. So we're well beyond the horizon for what the Congress has told NASA that they can spend, and that leaves a lot of options on the table. And until we get closer to that, and until there's a specific line item in the budget that says humans to Mars on it, it's difficult to say what's affordable and what's not affordable, because we have no idea what kind of budget we're working against, or what kind of time scale we're trying to do that on.
And it really does kind of depend on the commitment of both Congress and the White House in terms of what kind of vision they want to give NASA, because you can't just say let's go to Mars and then just leave it at that, right? I mean, you really need to look at some, like you said, a line item. And I'm no budgetary expert, but it seems to me like we got to at least get something a little more beyond 1 year at a time kind of funding to be able to do something as big as this. So anyway, that came out this week, and
Tony, can I add something to that?
you sure can. Go ahead, Rick.
So, what's really cool about Mars is we just don't have all the answers. We don't have it as a nation or as a space, NASA as a space program or a nation. You need a lot of ideas. So, for example, one of the ways to drive costs down is to use materials in the Martian system for propellant and oxygen, that kind of thing. And we don't even know enough about what's like on those moons or really where the water is or anything like that. So part of the problem is that it's a hard problem. And we need a lot of really cool and creative ideas. That's one of the reasons why I love this Hangouts right now, because some of the people online actually might help us find the ideas that we need to do this. And in the end, so it's a little bit of a flail, if you will, to trying to come up with something, to a plan. But you know what? It's because it's never been done before. And what we're about is trying to figure out how you do it. And these ideas that we're going to get, hopefully even from some of your listeners here, will really be key to making that possible. And the other thing I would say is a lot of times we view this as a United States budgeting effort, but in reality, when we did the landing site thing here, we had people from all over the planet suggesting landing sites at Mars. This is a human endeavor, and when we do this, it's not going to be one country paying for it. I am absolutely convinced that it's going to be a multilateral type thing, and the good news is we've learned how to do that. With Space Station and with a lot of the science programs, we've gotten really good at working together with our international partners. And I think that a lot of times you look at a problem, you go, oh, it's so hard, and then all of a sudden you reach this sort of moment where all of a sudden you realize it's really not that hard because you've got all the pieces together to go do it. And so I would just put that caveat. You're kind of in the period when you're listening to a congressional hearing where you're kind of hearing the sausage making, if you will. It's a little messy, but it's part of figuring out something really cool and hard.
I'm so glad you brought that up, because we're so used to thinking about doing things like going to Mars like we did back in the 60s. It was all the United States doing it by itself. We were going to go to the moon, and we were going to pay for it all ourselves. And that was a huge endeavor. We all know how much resources we poured into that to get that done in the time that we did it in, because it was a national commitment. But you're saying something like Mars is extremely difficult, and it is way harder than going to the moon because of a lot of reasons. And so, we're going to, I think, this sounds to me like this will be an international effort, right? We can't.
I think it'll not only be international, it'll actually be corporate too. I mean, we're learning a ton right now in terms of having private entities deliver logistics and soon people into low Earth orbit. I fully expect them to be involved in delivering stuff to the cislunar environment as well as out to the Martian system. We're going to have to be creative. We're going to have to do things in ways we've never done it before, and maybe that stretches our comfort zone a little bit. But you know what? Opening frontiers is about that, and I think we're totally, as a species, capable of doing that.
Yep, I agree. And even with other projects like the James Webb Space Telescope, that was a collaboration with the Europeans, right, Alberto?
Yeah, I was actually going to mention exactly that. I think very large, very, very ambitious projects, going to Mars or building, the largest, most complex space telescope ever built, they all require ingenuity from very different areas, not just industry and the government, but also from, as Richard was mentioning, from keen scientists that have ideas that perhaps are so different that they need time to mature, and they then come all together to produce these incredible endeavors for our species. I think it's very refreshing and very exciting, to all of us.
So we are just at the beginning of this, and I really we're going to go into this more as these Hangout series unfold. The bigger picture is a difficult one, as Rick points out, and rightfully so, and we've got people working on it and getting this done. It is going to take a commitment from a lot of government bodies, both just not only in the United States but everywhere. Actually, I think it's going to be a planet-wide effort. So we'll be revisiting this a lot as we go on. We don't want to just ignore the fact that this is a big problem, that it's huge, that we're just getting started on going to Mars. And so I now want to make that segue into solving the bits and pieces. Going to Mars has about 10,000 steps, and we're on like number 10, right? So we've got to cover some basic ground, which is what Rick was alluding to. We've got to solve some basic problems. When we started building the James Webb Space Telescope, stuff had to be invented just to make it happen. So the same is true for a trip to Mars. And here, back in October, a workshop was held. an international workshop was held to help answer the question, where are we going to land? Where are we going to go? And so let me have, which one should I get, Stephen or Richard to talk, or Rick to talk about this? Tell us about the workshop and what you were trying to do. How about you, Rick?
So I'll start, and then maybe Steve can add to it. We have a number of satellites, amazing satellites in orbit around Mars right now. You got the Mars Reconnaissance Observatory, for example, that are actually getting pretty old. And what we wanted to do is we wanted to start the process of trying to figure out where we're sending human beings on the planet, and use those assets that we have there to help start figuring that out. And so when they're getting old, and we wanted to be able to use them before we could do them. And so what we started is the process of actually trying to figure out where you might send human beings. And what we're finding is that it's really driving a lot of architectural things, if you will. So I'll give you an example. When we started, we didn't, I would say there's two major changes that have occurred in terms of the way NASA views a base on Mars. We actually now, thanks to the great work of the Evolvable Mars campaign, realize that when we set up a base, it's going to be a semi-permanent base, and that's the intent. And so we really want to make sure that that base, like McMurdo in Antarctica, has enough really cool science things to do there to keep, and diverse science things to keep our crews busy for a long time. In addition, to drive costs down, we need to be able to use resources at the planet, because otherwise you have to haul it all the way from the Earth, and the expense of doing that is astronomical. Steve has been involved with a jillion studies of these things. Sorry. And you really have to use resources there. So the longest kind of time obviously you can pull oxygen out of a carbon dioxide atmosphere, but the big second thing is not only this idea of a semi-permanent base, but the idea that we now know that there's significant water sources on Mars, and so that actually has now become a second major driver in terms of where we anticipate we will send people. And there's like 6 or so different types of water feedstocks, if you will, that we are really trying to understand, because they're probably going to be the drivers of where we send people. And so there's just a lot of unknowns, but we've started the process, and this is a multi-year process. We're going to need a lot of data from those satellites in there. Frankly, we're probably going to need another orbiter at some point to really help nail down the question about where water is. But we're still in the process of trying to figure that out right now. Steve, you have anything you want to add to that?
Well, the workshop itself was a first of its kind. Tony, you mentioned that there have been other workshops, and yes, there have, but those have been focused on where to send some of the recent, some not so recent, surface rovers that are there now. This particular workshop was a joint effort between the NASA's Science Mission Directorate, which is the part of NASA responsible for those surface rovers, and the human the HEO part of NASA, which is responsible for pieces, human spaceflight pieces like the space station. So when we organized this workshop, we looked at what do both of those communities see as important for, not, as Rick mentioned, trying to understand what's there, and from the human point of view, what do we need when we get there. And we announced this workshop and asked people to give us their ideas based on a set of criteria that we put together that reflected both of those communities. And we got some almost 50 different suggestions for where to put those. And there's a map behind me here that we can put a link to that shows where those proposed sites are. And there are many of them sprinkled across the planet, from north to south and at all longitudes. So, as Rick mentioned, this is the first step in the process. We need to look at those proposals, decide which ones of them make sense for a number of different reasons that'll come into play, and then we'll probably do this again at least once, probably several times, to try and refine those ideas, and at that point zero in on where we might send people.
Okay, so this is a big project that you guys are going to have to talk about this from a lot of different perspectives, a lot of different criteria need to be met. And one thing that both of you said that I just want to reiterate a little bit. So Rick was saying that one of the things is you want to pick a spot that is interesting scientifically, and then Steve, you said something that I want to just drill down in a little bit. It's not the same as picking something that you would send a rover to, right? So the spot where you would land a human being or the human crew is not going to be the same way you'd pick to say send a rover. Am I right? Am I right in saying that?
No, we send rovers there because there's something interesting to go look for, and I don't think that it would be less interesting. Well, the interest will be different. Let's put it that way. And humans are good at doing things at a pace and of a type that are different than rovers are. They each have their own strengths and weaknesses. So the concept that we asked people to look at or to consider when we put out this call for proposals was something we call an exploration zone. What we envisioned for the human missions, as was mentioned earlier, I think was mentioned earlier, because of the investment we have to make in sending people to Mars, we don't think we're going to go there once and stop, or go there a couple of times and then stop. We're going to go back repeatedly. So as we learned in the Apollo missions, having some kind of vehicle it greatly benefits the ability to have those humans that are there explore the surface. And
so like the lunar rover was something that they drove around the surface, something similar for Mars then?
Yes, although we're now looking at something that's more capable in the sense that it can last longer. It's like a miniature habitat. You can maybe envision a Winnebago kind of vehicle that you can live out of for several weeks at a time.
A Mars RV. Okay.
Mars RV. And we want to go. We haven't settled on a distance yet that it can travel, but for study purposes or for conceptualizing purposes, we said think of it as something that you could drive maybe 100 kilometers away from your home base. So we have this exploration zone that's about 100 kilometers in radius, and within that 100-kilometer radius, we could have several places, many places that are scientifically interesting that we could go to and explore and then come back from. And you could think of each one of those regions of interest as something that we're in the current paradigm where we would send a rover. So we could envision going to a Gale crater, for example, as one of the regions of interest that the humans would travel to and then return from. And then there could be other ones that are also within that rover's driving distance that they could go to the next time. So that it's a bigger piece of real estate, I guess, than what the rovers can deal with. But the kinds of activities I don't think are going to be fundamentally different than what we try to do with rovers now.
Okay, well here's what I don't get about this. Who was that? Was that you, Rick?
No, it was me. I had a question actually following this, because I mean, so what is the primary characteristics you're looking at for the landing zone? I mean, what is paramount in your mind that this zone has to have in order for you to have a good site to explore?
Right. I mean, because if you think about it, you guys, as Rick was talking about before, we don't even know really how we're going to get there yet. I mean, they're building the Orion spacecraft, I think, presumably to get us I don't know what role that's going to actually be, but how do you decide when you don't even know yet how you're going to really get there? What do you look at on these sites? What kind of criterion and characteristics do you look for at this so early in the game?
Well,
I'm going to do that with.
Right. You said it early in the game, and we did our best to come up with a set of criteria. We put that out there for people to look at, and we've seen the responses that have come back, and now it's time not only to look at the sites that were proposed, but also look at the criteria that we used and decide if that makes sense or not. And the next time we do this, we may change that criteria because we've learned something about how people would propose to go to places that meet our set of criteria that we created.
Okay, so
but if I might,
yeah.
To give you a sense, I mean, the criteria was to give you some. There was science criteria. So, for example, we're looking for different geological formations. We're looking for biological potential. We're looking for just our whole range of science questions where adding a human being with his or her creative powers is really high value added. I mean, there is a lot of science you can do without a human being, but there are some places where having a human being there is going to give us a quantum leap in terms of our knowledge. So that's one piece. And then the other part of this is the resource question. So, you know, oxygen you can pretty much pull out of the atmosphere. So water really starts becoming the driver, because that is a criteria in terms of having feedstocks to support the base. And I would add one thing to something that Steve was saying, is that that is a bit of a difference, or tends to be a bit of a difference, for where the robotic missions went to. They tend to go to very dry places right now out of what we call planetary protection concerns. In other words, we don't want to contaminate an area with human biologies, and also potentially pick up nasty microbes that would be dangerous for our crews as we learn to deal with that. And so the robotic missions have always tended to go to extremely dry areas. Well, with the human missions, almost by definition, are going where there's water. So there is a big difference right now in that trade space as well.
Is there much discussion about this topic of contamination? I mean, once we start sending people there, that all bets are off, right? I mean, with rovers, at least, we can sterilize them. We can try and make them as clean as possible to have the minimal amount of impact on the surface as we can. But once humans go, that's all out the window, right?
So there is a big discussion underway in terms of, you know, just how much we can do and can't do. I mean, there's a lot of factors that go into it. So, for example, you know, we have new technologies like genetic marker technologies right now that actually can help us figure out life, which we didn't have when the original policies were written. So, you know, and I actually personally believe that if there's life on Mars, it's probably not, we're not going to find it till humans get there with all their ingenuity and creativity to see it. And then
so no matter what kind of advanced labs we send, we're not going to really find it until we get there ourselves.
Well, that's my personal feeling. There is a big discussion in a lot of communities about that, and that's something we have to thrash through, frankly, to arrive at a good answer. And there also needs to be an evolutionary policy. The fact of the matter is that if you watch the movie The Martian, you know, we're going to have catastrophic events. You know, we're going to have HABs that decompress, and when they do, all those microbes are going out into the Martian, you know, environment. So the question is, how do you develop a policy that protects the science that planetary protection is trying to protect, and evolves towards the reality of what human beings really are? I mean, I think we're like 50% microbes by mass anyway, if I remember my numbers correctly.
Right.
And so,
some of us more than others.
Some of us more than others. And the point being is that we need a transition there, so we protect the science, and yet we also reflect the realities of human beings being on the planet. And frankly, you know, I spent a lot of time backpacking in the Amazon jungle. I'll tell you, you know, when I have a glass of water here with me, and I don't worry about drinking it. I do worry about drinking a glass of water in the Amazon jungle, having been very, very sick there one time. And we need to, part of these robotic missions needs to be driving to figure out really how dangerous that water is for people to drink and to use for other purposes. And that entails actually going to the water source in all probability.
Rick and Steve, I've got a question. This is Harley. As part of other things that you do, but also as part of the workshop that you had in October, was there? Well, could you be more specific about the kinds of precursor robotic missions, either in orbit or on the surface, that you would like to see between our 2020 mission and, say, the time that humans set foot on?
So I'll start and then maybe see what Steve says, since a lot of those would be done by the science mission director probably. I think we're rapidly, at the workshop, we had not only science guys, but we had engineering guys, human spaceflight guys. We really had an amazing mix of talent there. And there was a general consensus that the radars that we've flown to Mars to date really don't tell us where the ice is close to the surface. So that strongly suggests a new orbiter to actually tell us easily accessible water, ice, if you will. And then to be able to do reconnaissance of the planet to figure that problem out. Right now, we only know where the ice is deep, and we do know that it's near the surface because we can see impacts on craters and that kind of thing that show ice formations, but we don't really have a map of the whole thing. We need high-res mapping too. So that strongly, Harley, suggests an orbiter. And then sooner than later, you want to start sending robotic missions to that human landing site to actually characterize the site and to test and to validate, make sure it's not dangerous, and if nothing else, to also try to extract some of the ice and see what's in there, and to potentially even do samples. So and really, you're going to want to do several of them, because you may find out that you have a really bad thing that you didn't even know. So the sooner we can get those things into alignment, the better. But it strongly suggests an orbiter, and it suggests some landers to get there. And and that's needed also because we don't know how to land big honking things at Mars, as you know. Curiosity, I think, was a metric ton, if I'm remembering my numbers right. These things are, the human class landers are in the range, Steve would know the numbers better, of 18 to 27 metric tons, maybe 20 metric tons. That is hard to land at Mars.
It's also a little bit different than the lunar landers we were landing on the moon as well.
That's right. That's right. There's an atmosphere.
That's right.
And not only that, but we're planning on using potentially propellant made there. So there's a lot of difference between what we did at Mars. Steve, you have anything you want to add to that?
Well, back to your point, Harley, so there's questions we have scientifically, and there's questions we have from call it a civil engineering point of view. Because of this assumption that we're going to have some kind of way to drive around on the surface, it liberates us a bit from where we actually land the vehicles, because we can drive away from there, and we can start to pick out a landing site that's more favorable to those landers. So the landing site itself may be flat and boring and free of obstacles, and which also probably means free of anything that's of interest to the science community. But because we can now drive away from there, we can get to those more interesting places at our leisure. But that said, making sure that what we can see on the surface, the skin that we can see from orbit, it really does extend below the surface, so that our vehicles don't land on something that's not very stable or can't hold up the weight that we're trying to land at any particular time, will become important. So as Rick mentioned, there's probably a call for one or more landers going to the place where we think we want to send the humans to do the practical civil engineering kinds of reconnaissance around the place where we want to invest all this money in landers and habitats and that sort of thing in advance of the humans.
And if I might, one of the reasons why you have a semi-permanent base is basically a lesson we learned from ISS and McMurdo in Antarctica. You can pre and place things like supplies, logistics, spare parts. On ISS, when we have like a urine processing assembly break, we can launch something pretty quickly to get up there, whereas not an option at Mars, where it can take 6 to 9 months to get something out there, assuming your orbits are lined up. So the idea of a base where you can sort of pre and place stuff is really powerful, and actually I would suggest consistent with what's happened in the history of exploration.
Yeah. Well, I have tried. Oh, who was that? Was that you, Alberto?
Yeah, as usual. So I interrupt you.
As usual.
As usual, yes, I interrupt you. I was actually saying that it's we're also thinking, 10, 15, 20, 30 years in the future, and the role that robots could play it could be critically different. I mean, I'm working in Northrop. There's an entire group working on what's called cognitive autonomy. These robots actually learn from their surroundings. So I'm assuming that as we progress, we can actually use robots effectively to do what you, Stephen, and you, Richard, just mentioned. In terms of really scouting, for the best society, if you will, for exploration.
I think you do. Oh, I think you do that, and I also think it's not a robots and then humans. I think there's a symbiotic relationship between robots going all the way once humans are there. Because if you're assuming the humans are constrained initially within a 100-kilometer radius circle, I mean, there was a lot of interest even at the workshop about having like some sort of helicopter and/or aerial capability to extend the range of the human being. That's a robot.
Absolutely. Exactly.
Sorry, Steve.
So we've always assumed that as far back in these we call reference missions, that there would be some kind of cooperative effort by humans and robots. It's not going to be humans alone. It's not going to be robots alone. As I said before, they each have their strengths and weaknesses, and we're going to try and leverage those to the best possible advantage, so that whatever investment we're making for this site, we can learn the most from it with the best possible tools we have, and that means both robots and people.
All right, I want to get to the punchline a little bit about what this workshop is. And Steve, I apologize in advance. I have been searching the web furiously while you guys were talking to try to find that image that you currently have behind you, and I couldn't. I don't think I was able to find it. So I was wondering, can you tell us a little bit about what came out of the workshop as far as potential landing sites? What are the top candidates? And what I want to know is, do things like, well, you probably don't want to put it next to a big cliff, or you don't want to have giant rocks everywhere. I mean, that's the simple stuff. And as Rick said, you want some water nearby because we want to be able to. But what did you guys come up with? Did you guys reach a consensus at all at the workshop?
I think if the consensus that we reached was that we have some more work to do. I mean, this was the first time that we've attempted to do this, and there were, I think, 45 people, individuals, or teams that prepared something more than that, places where they would propose to send people on Mars. And everybody had their rationale for doing so. I think we polled the...
I have the map behind you, actually, up, Tony, if you want to see.
Oh, yay! Thank you, Alberto. You saved the day. Go ahead. All right,
so,
go ahead, Stephen.
Well, so we polled the participants afterwards to get sort of a straw poll. Think of it that way. I don't know if there's anything you can take from it more than that, about whether the case that was made by the teams that were presenting, if they made their case. And the feedback from that said about half, the participants rated about half of these as being good presentations and making a valid case for why we should go there. So you have somewhere between 20 and 40 places that are considered.
Yeah, there's a lot of dots on this map.
And as I said before, we now need to look at what those are. We need to compare them with what we think we can do technically, and we need to provide that feedback to these people that have taken the time and effort to put their ideas forward, and go at least one more round, probably several more rounds, to kind of hone in on where we might go. So I think we're too early in the process to say that there's any that we're ready to narrow down the place where we'd send humans. I think the lesson that I learned anyway from the workshop is that there are many places. We have a large, diverse range of places where we could send people, which is comforting in a way. It doesn't mean you're constrained to. We haven't found it that we are constrained so much right now that there's only one or two places where we could go. There are many places where we could go, and many interesting places where we could go. And we need to continue the discussion about what makes the most sense for sending humans on multiple trips to this interesting place.
Okay, I want to talk a little bit about the distinction between landing sites and exploration zones. There seems to be a distinction there, and I have a little thing up that I found on NASA's website about this. These exploration zone layout considerations. What is the difference between just landing and the exploration zone? Can you define that for us, Rick? What do you mean by an exploration zone?
So Steve referred to the 100-kilometer circle. So the landing is roughly in the center, and that's what you're seeing there. And then there's a 100-kilometer circle that we're assuming the crew through these rovers that Steve described can actually access those areas. And really, we're trying to validate that we think that the concept works, that we can do enough cool science and or get access to resources that we think we need to keep the human beings alive to have that concept work. And I think a major conclusion of the workshop was that concept works and makes sense. And so now we need to kind of go through a process of further defining it and then honing it down, and then ultimately, leading eventually to a landing site selection.
Okay, so I see a bunch of science regions of interest, exploration zones. all of these things are circled within that radius that you're talking about. And
Right.
you're talking about interesting science, presumably planetary geologic science, which is, of course, very important. But
so not just planetary or geological science. It's actually biological,
that's okay.
astrobiology.
Good. That's where I wanted. Why not just study biology there? I mean, like growing, whatever it is, growing things or your own, human responses in space. You can do that from anywhere, right?
Right. So we set up a team that actually to look at science objectives when humans get there. How would we best use people to actually further science? And that was a multidisciplinary team. It had astrobiologists, it had geologists, it had weather guys, it had the whole shebang. And they came up with a list of prioritized science objectives, and those are actually what we're driving our criteria, if you will, for looking for exploration zones. Steve, you got anything you want to add to that?
Well, if you can put that picture back up again, that's actually, we picked that as an example site because it had a rather large...
Sure, hang on. Sorry. I just changed everything around because I was about to go to the chats. Here we go.
I'll teach you.
Yeah, that'll teach me, won't it? Well, I'm used to having someone helping me drive, so I'm just... All right, this one.
While you're finding that, that site, if the people watching this want to go look for it and get up and close and personal with something like Google Mars or something else, that's called Jezero Crater. And it's interesting from the point of view, well, it's interesting from many points of view, but to illustrate the diversity that you could find at one particular site, that crater was filled with, appears to have been filled with water at one time. There's two inflow deltas on the western side of it and an outflow channel on the northeastern side of it. It's an impact crater, which is interesting by itself, and it has what appear to be river channels that fed it. So if there was life there, where you can look in those deltas to see if there's fossil remnants of that life. You can look at the effects of the impact itself on that particular piece of terrain. The farther away you get from it, there are other geological features that are of interest. So right there by itself, you can look at least past life, signs of past life. You can look at what happened with water when water was flowing on Mars. You can look at signs of impacts. You can look at I believe on the southeastern side of that crater there's a rather large uplift, so you can look at some of the other geological processes that would cause that to happen. And right there you've covered a rather large range of scientific interests that are not just geologic in nature. And that's what we tried to convey in this set of criteria that we put out to folks prior to the workshop itself, and is illustrative of the diversity of scientific interests that we would expect to find from this place that we want to visit multiple times. We would also expect that to layer on top of that the resources that Rick talks about is another factor that needs to be taken into account. So not only we're trying to find scientifically diverse places to go within this 100-kilometer kind of radius, but make sure that within that same zone there are some resources that we can tap into and make this a more sustainable exploration of the surface. So we're not bringing everything, the kitchen sink and everything else along with us when we send people there.
Yeah. Okay. Well, Alberto, what do you got up there?
Actually, I found this on the as part of the report released by the workshop, and I thought it was kind of interesting. I on your I guess on your left side you can see.
I'm not seeing you, Alberto. I'm not sure if anybody else. Are you?
You there?
I'm not seeing it. Do you guys see it?
No.
Sorry, we may have a connection problem, Alberto.
Yeah. Okay.
All right. So yeah, I'm not seeing your video right now. Well, one of the things that really just caught my attention, Steve, was when you said, when you're looking for life on Mars. I mean, that was just sort of, that just like, wow, that must be a huge consideration when you think about where you're going to put something, right? I mean, where you're going to want to go. I mean, to what extent do you think that's steering people's suggestions in these workshops? That's got to be huge, right? You want to go somewhere, gosh, where do you think a fossil might be?
It is, and it will remain so. And I think that it will be a rather central part of any criteria that we put forward. But as Rick discussed earlier, there's an ongoing discussion about planetary protection, both to make sure that we don't mess up things that are there, and that things that are there don't mess us up. So we'll have to be careful about how we pick those places. We want to be, it's another point in favor, if you will, of this larger exploration zone, so that we could find a place that is safe from a planetary protection point of view to land crews and to spread our microbes around, because we won't be able to cut that off completely, but yet not so close that we contaminate a place where we suspect that life forms may have a good chance of existing, and that we want to eventually study and explore.
Yeah, I mean, I would just add that finding life on another planet is really an amazing thing.
It'll be the biggest news, I think, in history.
Yeah, and I think there's some who want to run away from that, but the reality, that's the cool discovery.
Yeah.
And the human beings, I would just reiterate, are probably going to be needed to do, to actually figure that out if it exists there.
Yeah. And well, okay, so I have been reading a lot of your chat. This chat has been zooming by, guys, and thank you very much for all the stuff you've been commenting. Some of it I'm not even going to try to read out because it's not right. But some of these, yeah, well, that's YouTube, right? So, but some of these comments are pretty good. One of them is from a longtime listener and friend of mine, Woot Vanderheide. He's commenting, or he's asking. He's saying radiation isn't a big problem, right? Except for CMEs, you'll have to hide for those in a special compartment in your spacecraft and HAB. So, he brings up a good point. What about the effects of the sun and how it plays into your locations for where you might go? Does that have a big factor? Or do you just expect that whatever we send out there, whatever habitat's going to be shielded, and so don't worry about it?
Well, no. I mean, yes, it's a concern, and yes, we have to take that into account. Yeah, but these missions are long enough that they're not like the Apollo missions where we were out for a week and that was about it. So you could, your exposure was low. We're talking many years. Just the orbit mechanics by itself will require that these crews be gone from Earth for several years, 2, 3, 4 years at a time. And so you've increased their exposure from a probabilistic point of view. I mean, the solar particle events that you just referred to happen. They go up and down with the solar cycle, but they're also not predictable very far in advance. You can't predict 3 years in advance if you're going to have a solar storm on any particular date. So you have to take that into account, and you have to be sure that we protect the crew from those kind of events, and we will have to account for that in the designs. And there are several different ways of doing that, and we haven't settled on any one particular way. I'll point out another. There are two different kinds of radiation to be concerned about. One is the galactic cosmic rays, and the other one is the solar proton events or solar particle events. And there are different ways of protecting from either one. The planet itself will protect you from a lot of that. So just being on the surface itself, you've automatically blocked out half the sky. So you're protecting the crew simply by being on the surface. And if we put them in, if we can land in one place but set up the habitat somewhere else, we can start taking advantage of the local terrain and provide even more protection from that perspective. So radiation is a concern. We have to take it into account in our plans, and we will do so. But there are the local features, the planet itself, the terrain itself, are part of that plan, and they can be used to our advantage in protecting the crews from those kind of events.
Yeah, and go ahead.
No, I was just going to say, was there any discussion actually of, we heard it, I heard it at least from NASA at the time, so of instead of going to Mars, going to one of these moons, like Phobos, for example? Was that discussed during the workshop?
It was not. Our criteria said surface, so we did not branch off into either one of the moons.
I see.
George Caldwell is commenting. He's made a comment that says the astronomy community will need to come together more than ever, and so that leads me to want to ask: are these meetings very contentious? Do you get into a lot of arguments, or is it all very congenial? You know, you just sort of everybody is listening to everyone else.
They were not contentious.
Yeah.
They were Can you hear me? Okay.
Yes, we can hear you.
Yes.
They were amazingly engaged. It was really cool because it was fun to watch all these different communities come together, and really, I would say the overwhelming impression that you get coming out of that is that almost every community said, you know, we just don't know enough about this. You know, we need to learn and teach each other, and it was very collaborative. It was really kind of amazing. Steve, how would
I would say there were some hard questions asked, and there were some people who challenged some of the proposals that were being put forward in these events. But I think it was all handled professionally, and the video is out there on YouTube. You can go back and look at any one of the presentations and hear the questions that were asked and how they were answered and that sort of thing. So I think it was handled from that perspective. It wasn't a knockdown, drag out in any respect. I think it was all handled very professionally, but there were some hard questions that were asked of the presenters.
Yeah, I joke about it because I often wonder what the decadal survey that astronomers go through every 10 years. I always laugh and wonder what those meetings are like because they have to sit around and decide what questions are the most important, and then they have to rank them. And I just grin. I wonder what those meetings are like.
Right. That's why they check weapons at the door.
Okay. So, gosh, you guys are really commenting a lot, and this chat window is scrolling by really fast. I'm going to try and get some of the better ones.
These are great, by the way.
Yeah, are you guys reading them as well? So one of them had to do with this idea of water at the poles, and I wish I could remember the person. I'm sorry I can't remember your name or see your name because I just remember the comment, but it had to do with, isn't there water at the poles, and are those valuable or valid landing sites?
So Mars used to have oceans, and in fact, it's got frozen oceans that go much lower than the poles, down to like 35, 40 degrees inclination. And so that's really where you want to focus, because up at the poles it gets extremely cold in the winter time. You get these carbon dioxide snow buildups that are just massive, and thermally just running equipment and keeping people alive, even more specifically way far north, is extremely challenging. The sweet spot is somewhere down in the 35 to 40 degree range, where we probably can get access to relatively easily accessible ice and yet still have a better thermal environment for keeping people alive and keeping their equipment running, and it doesn't get subjected to those really nasty Martian winters. There's a lot we don't know to figure out where those ice deposits are. We don't even have the data yet, but it'll be somewhere. That's kind of the sweet spot where you achieve what I think the question is getting at, but also avoid the thermal issues.
That's
that
right. Yeah.
What about elevation actually on the planet? Because I saw I think a Instagram on their final report that shows that your distribution of elevation. It looked like you were going for very lower elevation, below whatever.
Elevation. You mean elevation in terms of height above?
Height above. I don't know if you could see
level
that. Yeah, exactly.
or latitude.
No, sorry. I mean sea level or whatever you guys call it. Right.
Steve, you want to take that one?
Yes, but let me go back to the previous one first. That Mars, if you aren't aware, Mars is inclined on its axis just like the Earth is, and so it goes through seasons just like the Earth does. And it's inclined about 25 degrees, which is a little bit more than the Earth. But what that implies is that both poles will go through periods where there's 24 hours of daylight and 24 hours of darkness. So we will have enough challenges to get people there and keep them alive and functioning as it is, without adding on the challenge of trying to have many, many months of 24 hours of darkness. So for those reasons alone, it's unlikely that we'll send humans to the poles in this first go-around. I'm sure we'll get there eventually, but I don't think that that's going to be high on the priority list for this first human venture. As Rick pointed out, you can find ice at lower latitudes, and we allowed for that when we asked people to send in their proposals. There are some features that visually and with some of the radar data that we have that appear to be debris-covered glaciers. And if that's what they turn out to be, that'll be a very attractive place to go. So there may be some high latitude sites, but not polar sites where we'll send crews.
Yeah.
Now, to Alberto's point, elevation, the atmosphere on Mars is helpful and hurtful in some ways. It helps us slow down, but it doesn't help us a lot. So the landing vehicles that we're talking about now, as they're coming in, we have to have enough time to slow down without putting a lot of G-forces on the crew as we're slowing down. So that means we need time, and that translates into lower elevation kinds of sites. So that's why there was an elevation criteria also put on the landing site. We just need time to help the vehicle slow down and reach the surface safely.
Okay, we're starting to run out of time. We only have a couple minutes left, but we've got a lot of comments here. George Caldwell's commenting, how will NASA send or create the resources necessary for humans on Mars? It seems a bigger problem to me than the landing site. Well, remember we said at the top of the thing, George, getting to Mars takes like 10,000 steps, and we're on like number 5. Okay, so it's really, we have a long way to go, but this is definitely one of the things that we need to
and don't forget to remind them we've got several months ahead of these first Friday each month on Footsteps to Mars. So lots of the topics that are being brought up by the folks question them will be covered in future Hangouts.
That's right. And so a couple of things that I already know I'm going to change for the next few Hangouts based on this one. But before we go to that part, I want to thank you. I want to thank our guests. I want to thank Richard. I want to make sure I get this right, so I don't say your names wrong. I want to thank Rick Davis and Dr. Steve Hoffman for joining us and taking time out for talking to us about the first human landing spots on Mars. And we hope, guys, that as you guys get drill down more into this, are you having more workshops? Let me ask you that.
Yes, we anticipate having another one. The water resource question is really a driver right now. We anticipate sort of splinter workshops to sort of hone down the water options, and then doing another workshop later on to really focus the efforts even more.
Can we get you guys back to talk about what you find out in later workshops?
I would love to. It'd be great.
That'd be wonderful to have you back. So thank you very much. Okay. Well, I want to thank you both for doing it. I'm going to go ahead and we're going to start signing off here now. But before I do, Harley, let's talk a little bit about what's in store for this Hangout. I mentioned at the top what the purpose of these Hangouts was going to be. We're going to talk about going to Mars. But why don't you give us a preview of some of the things coming up in future months?
Yeah, exactly. As we were talking very briefly at the beginning, there have been a number of scenarios supported by and developed within NASA. Steve referred to the Evolvable Mars campaign. There have been very attractive scenarios developed by the Jet Propulsion Lab, Aerospace Corporation, Aerojet, Boeing, Lockheed Martin, a whole variety of them that have been published and presented at various conferences. So we're thinking that in the next the first Friday in March and the first Friday in April, we'll bring some of those folks on board. Bring some of the folks who are actually doing the work for the new generation of scenarios. We don't want to forget our Mars scientists, the very exciting science programs in Mars that have already been carried out and are upcoming. So those are two broad areas we're going to have coming up.
So stay tuned for us at the first Friday of every single month, where we'll be having this at 3 p.m. Eastern Time about these different aspects that Harley was mentioning. Couple of changes I'm going to be implementing in future Hangouts, just so you guys know. It's too much for me to moderate a discussion and look at all of the social media stuff. So I'm going to have some moderators on the chat room next time. Woot, I hope you're listening because I know you reached out to me to offer help. So I'm going to be contacting you for helping and moderating these chats, and I will be able to get to more of your questions in a more organized fashion. I also looked at the Twitter feed, and I didn't see anybody using the Footsteps to Mars Hangout, so I don't have any comments there. But I will be making those changes for the next time, and I guess the next ones will be in early March. So we look forward to talking to our guests, and also Harley and Alberto. You're going to be back, right?
You bet.
Where else will we be?
We're going to be great. It's going to be great.
Awesome, as you always are. All right, guys. So thank you, Rick. Thank you, Steve, for your time. I want to thank all of you guys for watching. I hope you enjoyed our hangout, and we hope to see you again next month. Thank you all for watching, and as always, keep looking up.